Okay, I'm recording and I'm working on some stuff with Mathematica. Okay, rotation matrix, basic examples, details. Rotation matrix gives matrices for rotations of vectors around the origin. Two different conventions for rotation matrices are in common use. Rotation matrix is set up to use the vector-oriented convention to give a matrix M, so that M dot R yields the rotated version of a vector R. Transpose vector R gives the rotation matrices with the alternative coordinate system-oriented convention for which R dot M yields the rotated version of a vector R. Angles in rotation matrix are expressed in radians. Theta, degree, or theta, this degree symbol specifies an angle in degrees. Positive theta in rotation matrix, theta uv corresponds to going from the direction u towards the direction of v. Rotation matrix theta is equivalent to rotation matrix theta 1, 0, 0, 1. Rotation matrix theta w is equivalent to rotation matrix theta uv, where u perp w, v perp to w, and uv w form a right-handed coordinate system. Rotation matrix gives an orthogonal matrix of determinant 1 that in n dimensions can be considered an element of the group SO of n. Examples, basic examples. Generate a 2D rotation matrix for rotating a vector about the origin. Rotation matrix theta matrix form. Apply rotation by theta to a unit vector in the x direction. Rotation matrix on theta dot 1, 0 counter clockwise rotation by 30 degree rotation matrix with degree rotation that transforms the direction of 1, 1 into the direction of 0, -1. Rotation matrix 1, 1. Oh, it has to be 1 less. So 1, 1 to 0, -1. 3D rotation around the z-axis. Theta 0, 0, 1. Put that in matrix form. Scope, applications, properties, and relations. Properties and relations, but let me just upload this real quick. Add file, upload file. Rotation matrix, basic examples, commit changes. A rotation matrix is orthogonal I dot E, the inverse is equal to the transpose R equals rotation matrix theta inverse R minus transpose R. Simplify in the complex case, the rotation matrix is unitary. Rotation matrix 1 plus I 1 minus I 1 minus I negative 2 I 1 minus 3 I dot conjugate transpose rotation matrix 1 plus script I 1 minus script I negative 2 script I 1 minus 3 script I but here, I think, let me retype this real quick. 1 plus 1 minus negative 2 1 minus 3 there. Multiplying by the rotation matrix preserves the norm of a vector. Norm rotation matrix 1 plus script I. Did I just do that? It's a lot to type. Norm rotation matrix 1 plus script I 1 minus script I a dot dot negative 2 minus 2 script I 3 plus equals norm negative 2 minus 2 script I 3 plus that. Simplify. We have the same error. Negative 2 I 1 minus 3 there. The inverse of rotation matrix is given by rotation matrix with the inverse of rotation matrix theta, and add a space there, UV, put the closing bracket, is given by rotation matrix negative I didn't type the whole thing. Theta U UV rotation matrix theta 1 0 0 0 0 1 dot here the caps lock is on. Rotation matrix negative theta negative theta 1 0 0 0 0 1. Simplify the inverse of rotation matrix theta UV is also given by rotation matrix theta V U. I don't really feel like typing all that out again, so we're gonna add a 1 here. We're gonna make this guy positive, make that guy 0, and put a 1 right there. Not a minus sign. It's typed. If U or V is not real, the relationship is more complex. Rotation matrix pi divided by 3, pi, I want to enter it here, pi divided by 3, 1 0 1 1 plus I 0 1 dot rotation matrix pi divided by 3 1 plus I 0 1 1 0 1. Simplify. Yeah, that's pretty cool. But in 2D, the inverse of rotation matrix theta is given by rotation matrix negative theta rotation matrix theta dot rotation matrix negative theta. Simplify in 3D, the inverse of rotation matrix theta W is given by rotation matrix theta negative W rotation matrix theta 0 0 1 dot rotation matrix theta negative 0, 0, 1, simplify. If W is not real, the relationship is more complex. Okay. Come on. Rotation matrix theta 1 plus I 1 minus I, 0 dot rotation matrix theta negative 1 plus I 1 minus I 0. Simplify. The composition of rotations is a rotation matrix power, rotation matrix A. This is a lot of fun. This is great fun. Minus rotation matrix N comma A. Full simplify. Element. Let me see if this will work. An element of integers and a element reals. Something is not adding up here. Okay. Oh, I missed that. Still give me an error. Where? There we go. Okay, we're gonna make an upload. That was for properties and relations. Upload files. Rotation matrix. Rotation matrix. Properties and relations. Possible issues. The order in which rotations are performed is important. Rx equals rotation matrix theta 1 0 0 Ry equals rotation matrix CQ. I like the curly CQ. That's the curly phi. We're on curly phi 0 1 0. Rotating around X, and then Y is not the same. It's first rotating around Y, and then X, Rx dot Ry minus Ry dot Rx. Okay. Possible issues. rotation matrix, possible issues. That's cool. Any examples, rotations of a circular sector, graphics, table, geometric transformation, disk 2, 0, 1, negative 7, curly pi, pi divided by 10, 7 pi.
5 divided by 10 is 0.5.
What was that? 7 pi divided by 10, rotation matrix.
This is the top
A.
result.
Rotation matrix A, 2 pi divided by 5, range 5, plot range 3.1, that is not, there. Oh, cool. Mine looks a little bit different though. Okay, well, add file, upload files, rotation matrix, any examples, commit changes. Okay, I'm done.